Many researchers are now working to solve the most expensive and not yet fully understood problem of getting to net zero emissions. We are talking about asphaltenes. But what are asphaltenes? Simply micro rocks or tiny solids that might be produced if we inject CO2, or more commonly known as carbon emissions, into an oil reservoir. We all have heard about achieving net zero by 2050. One way to accomplish this is by capturing the CO2 emissions and injecting them underground. But where? In my backyard? No. One suitable place is the oil reservoir. However, this comes with a big challenge. Not all oil reservoirs are suitable for this purpose. In fact, this process has been performed for many years, and the most intricate problem is asphaltenes. Asphaltenes have blocked pipes, pumps, and even the whole reservoir, costing thousands per year for the oil industry. That said, let me explain you how we study this problem in the lab. In a high-pressure, high-temperature equipment called PVT cell, where the oil and gases like CO2 are mixed, we simulate underground conditions. Pressures over 10,000 psi and temperatures over 300 Fahrenheit are reached in this cutting-edge technology. Yes, I know, it sounds like it can explode anytime. Well, not really. It is totally safe and well tested. We can also see different liquid and vapor phases in this camera. It is really cool to see how liquid and gases phases changing in real time. The solid detection system called SDS shows us the microsolids like asphaltenes that come out from the oil and CO2 mixtures. We build relationships among pressure, temperature, and volume to predict under what conditions asphaltene precipitation is more likely. Choosing these pieces of equipment is not easy. One single experiment can last months. Fortunately, all my efforts paid off when all the data from the experiments are plugged into a computer model to predict under what thermodynamic conditions the injection of CO2 underground can face asphaltene problems. We all together are building a new and greener world. Thank you.